All right, so I'm going to be working problem 29 from page 156. And it says, a stubborn 120 kilogram pig sits down and refuses to move. To drag the pig to the barn, the exasperated farmer ties a rope around the pig and pulls with his maximum force of 800 newtons. The coefficients of friction between the pig and ground are mu sub s, or coefficient of static friction, is 0.8, and mu sub k, or coefficient of kinetic friction, is 0.5. Is the farmer able to move the pig? So the first step in this one is I'm going to draw my free body diagram. And then the main idea here is to consider the difference between kinetic friction and static friction. Like we talked about, static friction, if I'm pushing on an object and it's not moving yet, as I push harder, the static frictional force increases up to a maximum. And then when it hits that maximum and surpasses it, my applied force, then the object's going to start sliding, and we start looking at kinetic friction instead of the static friction. So I have to decide in this case, is the applied force stronger than the maximum static friction, and therefore the pig's going to start sliding, or is the pig's static frictional force stronger than the applied force and, well, equal to the applied force, so that the pig doesn't accelerate, doesn't slide. So I'm going to go ahead and draw my free body diagram. Here's my pig. And I know my force due to gravity is going to be the pig's mass times the acceleration due to gravity. The pig's mass is 120 kilograms times 9.8 meters per second squared. And so I'm going to get 1,176 newtons for this. There's no indication that the pig is accelerating upward or downward, and so my normal force is going to be equal to my force due to gravity. These are in balance, and that's also going to be equal to 1,176 newtons. And then I have this applied force on the pig. It's being applied by a rope, and that force is 800 newtons. So now that I have my free body diagram, my second step is to calculate the net force on the pig in the horizontal direction. Well, my second step is to calculate the maximum static friction that is possible to see if it is large enough to keep the pig stationary, to see if it is greater than or equal to 800 newtons, the applied force. If there were any other horizontal forces on the pig, I would first need to figure out what the net force was before I did this step. But all there is in this problem is just one force. So, and then that's it actually for this problem. Those are all the steps I need to do. So I'm going to find, I know that there is a frictional force. I'm going to try static friction first and see. I know that the force due to static friction is equal to mu sub s. The maximum force due to static friction is equal to mu sub s times the normal force. So if the farmer is applying less than this maximum, then whatever the force of static friction is, it'll just balance out whatever the farmer's doing up to that max. All right, so in this case, the coefficient of static friction is 0.8. My normal force is 1,176, and so I got 940.8 newtons as my maximum here. Now, in this case, is the static frictional force going to be 940? No, because the farmer is only applying 800. So over here, I will also have an 800 Newton force. It's balanced. My pig is not going to move. So pig does not accelerate. It's not going to slide. We don't have to worry about the sliding friction at all because the static frictional force is able to balance the applied force. All right, we'll leave that for just a second and I'll close it out. Thank you.